Hi, good morning and welcome to an ETP hosted webinar, Kickstart Your Low Carbon Innovation Journey in the Energy Distribution and Infrastructure theme. My name is Jennifer Keegan and I'm the Business Development Manager for the Energy Distribution and Infrastructure theme at ETP. Could I ask everyone to mute your microphones so that we get as good a sound quality as we can from Zoom? And any questions are very welcome via the chat and they will be addressed at the end. So the agenda this morning, we have 3 presentations today. I will firstly position ETP, who we are and what we do, particularly in relation to Scottish SMEs that we work with across a number of energy sectors. We have Stephen White, who I've worked with very closely over the last 4 years and is the Senior Business Development Manager at the Power Networks Demonstration Centre, and he will tell you all about this Strathclyde facility that's based in Cumbernauld. And lastly, we have Derek Holliday, who is based in Tripoli at Strathclyde. He has led the Strathclyde effort in the UKRI, driving the Electric Revolution Challenge. That has resulted in successful funding for the DARE Centre in Scotland. So again, please ask any questions via the chat and we will address those at the end. So ETP is a research pool organisation. The research pooling initiative was created by the Scottish Funding Council in 2004 to encourage researchers across Scotland to pool their resources and respond to increasing international competition. There are 11 Scottish Funding Council supported research pools that focus on a variety of different sciences and technologies. ETP focuses on energy. So the ETP is a partnership and alliance of 13 Scottish universities that are involved in energy-related research, development and demonstration. ETP supports the Scottish Government in their challenge to achieve their net zero targets by helping Scottish SMEs that are innovative and creating new products and processes that have a low carbon benefit in the energy system. So by matching these companies to the best academic resources and facilities, we help to speed up the development and the deployment of the technologies by funding some of the early collaborative work. So the Knowledge Exchange Network is the area where ETP and the team of business development managers are most active. KEN is a 3-year funding programme exclusively for Scottish SMEs, and the current funding round closes on the 31st of March 2022. The funding is served on a first come, first served basis. All projects must be completed by the end of March 2022. So if you're thinking of making an application, please do it sooner rather than later. So KEN project funding for SMEs. So our fund is currently open. The application process is very straightforward and very fast. The type of project we fund is very clear. The company who are applying for the funding must be a Scottish SME or have a very strong Scottish presence. The project must have a net CO2 reduction in the body of the project for the technology. The project must focus on a new product or a process that has a market that the company can then go on to sell it to. A successful project should lead to the protection and the creation of Scottish jobs, increased turnover and profit for the company, and have positive economic impact. There are 2 types of ETP grant. One is up to £10,000 available to pay for work by university academics. The other is a smaller £3,500 project for work done by a student. That is still overseen by an academic, but the student does most of the work. The company contribution to this project can often be in kind rather than cash. The application process is very straightforward and has 2 stages. Once we submit an application, we have a decision within 7 days. And our 10K projects usually last for between 2 and 3 months. So the Knowledge Exchange Network aims to support innovation in the Scottish SME community. to signpost SMEs to the best expertise, facilities and funding options, and to assist the energy transition. And all of these things in turn creates a positive economic impact for Scotland. So ETP acts as an interface, a signposting service between academia, the public sector and industry. So the Knowledge Exchange Network team of BDMs, ETP currently has 7 active energy themes, soon to be 8. We have an additional colleague covering transport who will join us next year. Our energy conversion and storage theme is based in the University of St Andrews. That was a current vacancy, but that has been filled and the new person will join us in March next year. I'm based in the University of Strathclyde. I work closely with EEE and the Power Networks Demonstration Centre. EEB, that's Energy Efficiency in Buildings, is hosted at Heriot-Watt University and is looked after by 2 BDMs who job share, Laura Finlay and Tom Bent. Our marine theme is based in the University of Edinburgh, with Business Development Manager Norman Morrison being shared with Wave Energy Scotland. Our heat theme is based in the University of Glasgow. Our BDM Emma Church is shared with the Construction Scotland Innovation Centre. Energy Systems is also based at Strathclyde, and BDM Natasha Madeira is also shared with the Energy Systems Catapult. And last but not least, Alex Loudon is our wind theme BDM, and he is shared with OREC, the Offshore Renewable Energy Catapult. So the team is based throughout Scotland in different universities, and most of us are shared with other organisations. So the innovation journey for SMEs, I think this slide demonstrates very nicely the funding landscape, with smaller funding available for very early stage work at the bottom. And as we move up the ladder, the funding gets a bit more serious the further up the technology readiness levels that the development gets to. At ETP, we try to ensure that companies are leveraging as much of the available funding as possible. At up to 10K, ETP funding can be a great way to start a collaborative relationship with a university or an academic, but often it's not enough to complete all the work that a company needs to have done. So we quite often use this funding escalator to map the next logical step where the company might apply to for funding. We've had several companies go on to make successful KTP applications. Those are nearly at the top of that funding escalator. They have an average value of £200,000 with an 18-month to 2-year duration. And we can track many of the companies that we work with from the very bottom to the top of that escalator. This last slide is a little busy, but I wanted to share this with you because it charts the project and the Knowledge Exchange Network for the energy distribution and infrastructure theme over a period of quite a few years. From the very first round of KEN, 7 of the companies that ETP supported went on to be awarded funding from Innovate UK. 4 of the companies from KEN 2 went on to be awarded significant funding from Innovate UK. Gravitricity are a great little technology company working on a gravitational energy storage device. They received ETP funding in the KEN Phase 2. That funding was used to work with expertise at the PNDC. The PNDC provided a letter of support for their Innovate UK application, and they went on to be awarded £650,000 to move forward into the next stage of the project, which is a 250 kilowatt demonstrator that should be built next year. SDC Industries are a small company in East Kilbride that manufacture electrical power quality and energy efficiency equipment for commercial and industrial sites. They were one of the first companies I met when I started working with ETP. They knew how they wanted to develop one of their devices, but despite spending money on electrical contractors, specialists, consultants, they couldn't get the prototype to work. I introduced them to academics at Strathclyde who immediately saw the way forward and understood what work had to be done. We applied for the Scottish Funding Council voucher at the very bottom of our innovation ladder. We then applied for ETP funding to do initial work on the design, and next year they're going forward with a KTP application. So the ETP funding most of the time is just the start of the innovation journey. and the beginning of something that goes on to be much bigger. So there's lots of good reasons to get in touch with ETP and to look into doing a project with us, because as you can see from some of the names that are on this slide, some of you will know companies like Smarter Grid Solutions, Synaptech, Whittaker Engineering. They were also a successful KTP application. There are a lot of names that we're seeing a lot on social media that these companies have been going on for years. And, you know, in Ken 1, which I think was around 5 years ago, they were doing small projects with us. So just a reminder of our Ken partners, Scottish Enterprise, the Scottish Government, Highlands and Islands Enterprise, and ERDF funding, and some of the organisations which share business development managers with us. So you're very welcome to contact me separately to today's event, and also any questions via the chat that we'll get to at the end. But without any delay, we'll move on to Stephen White, because I know he has another commitment that he has to rush off for. So I will stop sharing my screen, Stephen, and ask you to take over. I think you're still on mute, Stephen.
Yes, I am. Thank you, Jennifer, for that. Hopefully you can see my slides now. I'll assume that's a yes. So thank you very much for ETP to invite us along, invite me along this morning to present during this session. As Jennifer said at the beginning, my name is Stephen White. I'm the Senior Business Development Manager at the Power Networks Demonstration Centre, the PNDC, as part of the University of Strathclyde. And really just wanted to take the opportunity to present this morning and give you an overview of what the PNDC is and the work that it is involved in, how it also interacts with organisations such as the ETP, and also you'll hear from another one of my colleagues from within the university, the wider university, Derek Holliday, who will talk you through some of the work ongoing within the electrical and electronic engineering department, of which PNDC is part of. So, assuming that you can hear me okay and also see my slides, I'll rush through these. As I say, I do have to drop off the call at about 11:30. If you've got any questions, I've got my email at the end of the presentation, and please feel free to drop me a line if there's anything that I can help with. So just a very quick overview of PNDC and what it was established for. So really, it is a dedicated energy systems research, development and demonstration facility. It was founded and created, the facility constructed in late 2013 and opened in early 2014. And as I mentioned, very much part of the University of Strathclyde as one of the university's industry-facing research centres, really with a focus on de-risking and accelerating innovation across the energy networks domain, and bringing new technologies into predominantly electrical power grids, so both distribution and transmission networks, but also now spanning into looking at heat and transport networks in a much bigger way as well. We have around about 15 to 20 research and development engineers within PNDC who are dedicated to activities within PNDC, but we can also tap into the wider base of expertise across the university, which obviously has huge advantages. Most importantly, we work very closely with industry, and we're very much focused on that, and we are an open access facility. So anyone who wants to tap into the facilities, the infrastructure that we have at PNDC, or else the research capability is able to do that. And you know, we encourage people to get in touch with us if they feel they have a challenge that we could potentially help them solve. So we talk about what we're aiming to achieve, and really it's about bridging that that gap between the academic world in terms of early stage research, early TRL, technology readiness level development, and really trying to accelerate that towards commercial deployment and business as usual. So PNDC really sits in the middle of that scale, looking at system level testing and validation, and looking at proof of concept of new technologies prior to their implementation within live customer connected energy networks. Our portfolio of work that we're involved in is really split into three areas. The first here is what we refer to as core research, and that's a collaborative research program that is funded by our industrial partners, or as we refer to them as members. They are able to direct and steer the program that we deliver, and obviously are able to then share the outputs from that program as well. And you'll possibly see some organisations there that you might recognise. That is us working very closely with distribution network operators, DNOs, who manage the electrical infrastructure from sort of the transmission level down to your doorstep and into people's homes, and also some non-utilities in the likes of Cisco, Vodafone, and other organisations who are involved and very interested in the kind of macro trends in the sector, which sees an increase in things like digitalisation and decentralisation of the energy system and the technologies that will underpin and enable a lot of that. The other side of what we do is what we refer to as commercial projects. So we engage with organisations on a contract basis, on a project by project basis, and that's where we are delivering a service to them. And obviously any arrangements are on a bilateral basis with those types of engagement. And that is actually the majority of what we do, either testing, demonstration type activity, modelling or simulation. And then lastly, the kind of smaller piece is in around grant funded projects, where we can get involved in a range of those through different funding mechanisms, whether it be through sort of European funded programmes, down to sort of Innovate UK grant applications. We can be involved as a partner or as simply a subcontractor delivering part of that project. In terms of PNDC and the facility itself, I won't delve into too much of the detail at the moment. I believe these slides will be circulated, and if you have any more technical questions to follow up on, please do drop me a line following the presentation today. But really what I wanted to highlight is effectively what we have at PNDC is an 11 kV distribution network at scale, and everything you would find within that environment is as you would find out in the live grid type environment. Our USP is our ability to isolate ourselves and island ourselves from the local grid where we're connected, and that allows us then to change network parameters within our test network to introduce faults onto the network as well, and that is all about the acceleration of testing, of de-risking new technologies to ensure that they'll stand up to certain network conditions before they are deployed and implemented within, as I said earlier, customer connected distribution networks. We also have a lot of simulation and modelling capability on the power systems side. So again, we can simulate and model much larger systems than what we have physically at PNDC, and also we also reach into the communications area through some of the partners that we work with. So looking at next generation communications, IoT, and obviously cybersecurity being a massive part of that in the sort of critical infrastructure space as well. So how do we work with SMEs and some collaborations that we've had with the ETP in the past? There's sort of two main routes to doing that. We have an associate membership category, which is specifically aimed at early stage companies and SMEs. And that's really about offering a platform for those organisations to showcase their technology and those solutions and to engage with potential end users, which may be the utilities themselves. We've had a number of examples of organisations we've engaged with in that space. And then there's simply engaging on a project basis, and that's where an organisation may be coming to us through ETP, for example, where they want to deliver a specific package of work that we can help them scope, and also to be involved in applying for the funding as well to do that. And then obviously we go on to then deliver a piece of demonstration or validation work that supports and gives an independent view on the technology that company is looking to commercialise or deploy at scale. So there's a few routes there that we can engage with, and I certainly encourage you, if anything from today is, if you're looking for more information, please do get in touch with either ETP or ourselves on what we could potentially do together. So moving forward into the future, a bit about what PNDC is looking to do in terms of expanding our scope, so to speak, and that's with particular reference to whole energy systems, and that's moving away from being solely focused on the electrical infrastructure that the UK energy sector is so dependent on in terms of facilitating new low carbon technologies and new sources of generation, and that's really starting to look at in terms of achieving net zero ambitions that both the UK and Scottish government have laid out, is saying, well, what else has to be done in order to support that? And that's taking this whole system view, looking at electricity as just one vector in that mix, but also looking at other areas such as heating and also transport as huge opportunities and also challenges in being able to decarbonise those and ahead of those binding net zero targets. And what we are trying to do in PNDC is looking to expand our facility, our capabilities in moving into that space, to build upon what we have today in the electricity domain, but also to then look at interfacing at a system level with heat networks and also transport systems as well. So looking at EV, looking at potential hydrogen as a fuel as well as an energy store, and also looking at decarbonisation of other vehicles and transport systems, looking at aerospace and marine as well as another focus of that, and my colleague Derek will touch upon some of that work in and around the Driving the Electric Revolution challenge that UK government has set out. We're also looking to engage with new organisations and stakeholders across those domains, and would certainly encourage and invite people who have technologies in those areas to please get in touch with us, and we're more than happy to look at how we could support to develop those jointly. And also really looking at this ecosystem that is being developed, not just in Scotland with some of the partners there that I've highlighted, but also in further afield in the UK and beyond. So I think there's a real sense of things are happening in the sector, and we certainly see ourselves playing a key role within that as well. One particular initiative that we are developing with the Energy Systems Catapult is around this whole Energy Systems Accelerator, and that is looking to build linkages with the Energy Systems Catapult Living Lab, which is already a successful platform for providing access to SMEs, to early stage companies to engage with effectively 100 connected homes with real live people living in them, who are consuming energy in different ways through heat and electricity, and being able to then play through some of that in terms of the data being taken from those homes in real time, and interfacing that with the PNDC's test environment, and then being able to play back different market signals, different scenarios, and future-proofing some of those use cases into commands that will then be played back into those homes that are connected up to that living lab. So that is a real program that we're working on at the moment, and we hope to say a bit more about that as we go into next year. So really, in summary, as I said at the outset, the University of Strathclyde as a whole, PNDC has a real sort of industry-focused approach, some real heritage, particularly in electrical power systems, but also in looking at low carbon technologies, and also the policy and the regulation side, which go along with those as well. We're looking to expand PNDC in terms of the facilities and the types of engagement that we have with industry, particularly in those new areas within heat transport on a whole systems perspective. And then we really look to continue that sort of real world systems integration piece, and being able to offer that sandbox environment that allows us to de-risk and future-proof solutions that are going to take us forward into achieving net zero. So that's all I really wanted to cover today. As I said, I very much encourage you to get in touch. If you want more information, you please visit our website, pndc.co.uk. That you can join our mailing list on there and receive updates, or also join us on our social channels as well. And I've left my email address there. So again, once the slides come out, please do get in touch if there's anything particular that we could support you with. So that was all from me. I think I'm just about bang on time, so I will hand back over.
Thanks, Stephen. That's excellent. Much appreciated. Thank you for joining us today. And Derek, it will be over to you next.
Okay, just let me give me a second. I'll try and share my screen. So I'm hoping now that everyone can see a slide which says Introduction to University of Strathclyde, etc.
We can, yeah.
Excellent. Okay. So my name is Derek Holliday. I'm a member of the academic staff with the University of Strathclyde, and my area of interest is power electronics, electrical machines and drives, and that fits within a much broader sort of power systems type activity within the department. And so my remit today, if you like, is to give you just a bit of an overview of some of that activity at the University of Strathclyde, and then to lead into and give an overview of the Driving the Electric Revolution challenge, which was mentioned at the beginning of the presentations, and with which I've had a fair bit of input. Okay, so just by way of a very brief introduction to our university. So University of Strathclyde is based right in the heart of Glasgow. Our main building is the Royal College building, which is the one on the top right of the slide, built in 1904. The university traces its history back a bit before that, but when it was initially set up, it was set up as being a place of useful learning. And that's an ethos which we very much hold dear to this day. And we like to ensure that we engage strongly with industry, doing relevant industrially focused research, and supporting these technology developments, providing real solutions for real problems. So the Royal College building is largely where the academic staff are located. If you look to the left, you will see the Technology and Innovation Centre, which is a much more modern building, which is a couple of hundred yards along the road from the Royal College building. And that was opened in 2015. And that's a very much a state-of-the-art facility, which facilitates this engagement between industry and academia, and which also houses state-of-the-art laboratories where the majority of our research team are actually located and from where they operate. The bottom left there is another picture of the PNDC. So as Stephen has already described, that's a unique facility within the UK, which allows us to carry out system testing and development at realistic levels on a real power system. So we're able to prove out designs and concepts and equipment and so on before final deployment, but by clients in the system. And on the bottom right there, again, it just gives you a sort of rough number, which talks about the sort of size of the department. So collectively, between the academics and the student cohort and the researchers, we've got roughly 1,500 people within our department. Again, just a few more facts and figures. I won't dwell on that. That's giving you just a little bit more of a breakdown as to where all those different staff actually reside. But we have a very good complement of very well qualified postdoctoral researchers and our PhD student cohort as well, who the academics work clearly very closely with in conducting the research. So the department is broadly split into two institutes. The one on the left is the Institute for Energy Environment, and the one on the right is Institute for Sensors, Signals and Communications. And very roughly, the disciplines are split according to effectively the size of the amps and the volts. So on the left-hand side, it tends to be the high power stuff that's carried out within the Institute for Energy Environment. And on the right-hand side, it tends to be lower power stuff. But that's not to say there's not a lot of crossover between the two, because clearly for example, some of the sensor work, which is being carried out within the Institute for Sensors, Signals and Communications is very relevant when we look at diagnostic testing and so on, and measurement within the Institute for Energy Environment high power applications. Within the Institute for Energy Environment, we have, if you like, 4 academic groups within the university and the main campus itself. And those are the Advanced Electrical Systems team, the High Voltage Technologies team, the Power Electronics Drives and Energy Conversion team, and that's the team that I'm a member of, and the Wind Energy Control team. And then the PNDC, the Power Networks Demonstration Centre, it's affiliated to, it's part of the department and part of the institute, but it's located at Cumbernauld, so it's a little bit away from the city centre. But we do work very closely. We actually have PNDC academics and employees on site within the main campus as well. So there's a very, very tight link between the two. So what I thought I'd do now is just to go through and give you a very brief overview of the general research areas, in particular focusing on the advanced electrical systems and on the power electronics drives and energy conversion group, because perhaps they're the ones that were most relevant to the DER centre. So again, I don't intend to spend a lot of time looking at this. Really, it's really just an overview, and the slides will be available after the presentation. There's a lot more information that you can find out by looking at our websites and linking through to the Institute and to the various group websites. And also feel free to contact me or anyone else whose email address is on the presentations today, and we can provide you with any further information that you may need. So the Advanced Electrical Systems group, the AES group, has a lot of activity across a broad range of applications. And I think as a very broad generalization, you might say that they're quite a, they're more of a systems type group. And I'll draw that distinction between their work and the work that we do later on. So you can see the kinds of things that they do are within power systems, protection and operation. They look at fax devices. They look at systems relating to HVDC systems, bulk energy transfer, energy storage, marine and aircraft systems. And these are very big themes within the AES group and their activities on campus and also at the PNDC. Power system analysis and renewable integration. So again, a lot of activity in looking at the system aspects of developing, of integrating things like solar, wind energy and marine energy systems onto the grid. And also looking at how these activities actually affect the broader operation of the grid as well. Intelligent systems, well, artificial intelligence, Internet of Things, big data, all these topics are becoming increasingly relevant in the power systems arena with asset management, sensing, diagnostics, maintenance, scheduling, all of these activities. So we have a very strong activity in AI. And again, this links in, as I mentioned earlier, there's crossover between our activities in our institute and those activities in the other side of the house, if you like. So there's a lot of good crossover between the two sides here, because there's a very strong IoT, Internet of Things activity and AI activity also within the other institute within our department. Markets and economics, again, a strong activity there, effectively looking at the various factors that affect how the energy markets actually work and influence that. And we have a number of people who sit on panels and committees who advise on this kind of activity as well. So a very, very strong activity there. Marine and aero systems, a good example of that would be our university technology centre that we have with Rolls-Royce, where we work very closely with Rolls-Royce in developing novel and future solutions for propulsion systems and for power generation and transmission and distribution systems within aircraft and aerospace applications and that sort of thing. Asset management, again, this kind of, I guess, draws on in some ways aspects of the measurement and monitoring activity that we have. And again, looking at ways of optimizing how the various assets within a system are managed. Some examples of that might be, we have strong activity with sort of clever management strategies, for example, for scheduling maintenance on offshore platforms, very expensive thing to do. So we have a lot of work, industrially focused work, looking at those kinds of areas. Some other activity we've been looking at as well is we can extend the plant lifetime of, for example, nuclear facilities. So we've carried out some diagnostic work on that and been able to predict or to enable, if you like, the extension of lifetime of nuclear facilities based upon those particular measurements and our analysis of the health of these facilities. Advanced sensor for power and energy industries. Again, I've kind of mentioned this. We've talked about the importance of sensing and so on. So there's a lot of activity going on within the AES group and also the other institute within our department, looking at how we can use fiber optic techniques, for example, to measure various phenomena within power and energy systems. That will enable things like fault diagnosis, preempting faults, maintenance scheduling, and all those kinds of activities. This is just an example of one of the laboratories. So the AES group, along with the power electronics group, we occupy a suite of laboratories in the TIC building. And this is just as a sort of example of some of the facilities that are within the AES distribution network and protection laboratory. So we have a lot of configurable power supplies, 100 kVA capability on campus. And on the right-hand side there, you can see just an example of a sort of representative loads. There are all sorts of other representative loads that we can have as well. And also in the middle there, this is representing the kind of control platform that we have. So you have a lot of hardware in the loop facility there. And this really enables us to have a complete system overview of a realistic system. So for example, this type of facility might be used to replicate a ship's onboard electrical system or the onboard system for an aircraft or something like that. And it enables you to then, test control systems or test a piece of hardware within that system and get a really good idea of the true operation of that piece of equipment or control system or whatever it is within the real system environment. Moving on to power electronics, again, I'll skip through this. So there's currently 5 members of the power electronics team, and in total we have about 30 odd researchers and postgraduate students within our team. Essentially, what we do is we are interested in developing power conversion solutions pretty much across all power levels, ranging from individual power modules to, as it says, to specialized solutions, and pretty much for any application. We have experience over a very broad range of application areas and power levels. And I guess the main distinction I would draw between us and the AES group is that perhaps we operate more at the circuit level. So we are capable of doing, if you like, from the circuit end of things right through to the system study, but we have a deep understanding at the component level and at the power converter level of how these things actually operate and what the interaction between these various systems might actually be when they're deployed in a system environment. And again, I've mentioned previously, we have a nice laboratory environment in which we're able to work with. It's pretty well equipped with state-of-the-art equipment. So again, I won't spend too much time on this, but just really give you the headlines. Our key areas of research are typically high efficiency power conversion for a variety of applications, whether they are for grid applications or for automotive or aerospace. We are typically targeting in excess of 99% efficiency with their power converters, and we're exploring the use of semiconductor devices, including the new wideband or newer wide bandgap semiconductor devices, but not exclusively. Clearly, there's still a place for silicon within this market as well. So we're looking at how we can use those, how we can combine those to come up with hybrid solutions to give us the optimum power conversion topologies and strategies and so on for whatever the application might actually be. One of the things that we do pride ourselves on is our ability to produce very high quality demonstrators. Clearly, within our laboratory environment, we are limited to the power levels that we can achieve, but we are very confident that we do create our prototypes, that they're all scalable. And indeed, if there is a requirement to build anything that is higher power, then we are more than capable of actually doing that as well and assisting building up systems which are for much higher power levels. High power converter systems is another area of our kind of interest and expertise. And so again, this is the kind of thing that you might see deployed in a power network. So it could be for interfacing a renewable energy source like a photovoltaic array or a wind farm or something like that. It could be a power converter for an HVDC system or something like that as well. So we're interested in topologies. We understand the difficulties of things like series and parallel connection of devices, and we have in the past developed solutions for that. And again, as it says, we've done some work on solid state transformers as well, and even high power current source converters. That's an example perhaps of one of the applications of one of our higher power converters. So again, these things are, this one was for Taiwan rail, but there's quite a lot of these things rattling around on the UK rail infrastructure. So this was a development of a fully electric drivetrain for one of these locomotives. Control of converters for grid interface. So again, as it says, and I've kind of touched on this already with things like wind farm integration and photovoltaics and so on. And so we're interested in understanding the actual converter operation, but also the interactions of these various converters and how the operation of these converters and the control systems might affect the wider energy network as well. And we've been involved in some quite big projects looking at these aspects. Some of the ones, for example, that were funded by the EU through their Best Pass, for example, project portfolio. Again, another example of some of the stuff that we've built in-house. This is an example of a multi-level modular converter, which was built for one of these EU projects. And on the right-hand side, again, just giving a bit of an overview of our laboratory and one of the converter systems that we built up there, which was used to develop a wind farm integration strategy. And finally, DC networks. So again, HVDC is being pioneered, explored as one of these methods of bulk power transfer across the country and between continents, for example. So we have a lot of expertise in the converter development for that, the converter control for that, and also looking at the systems aspect of that. And we've done quite a lot of work on that. I think Strathclyde's been involved in, I think, the 3 main European funded projects in this particular area in recent times. And we've also done some work with companies, for example, like Mitsubishi Electric, on helping them develop their strategies for getting into this kind of market. So that leads me on to the DARE Centre. It's maybe just another few minutes just to cover what this is. So the Driving the Electric Revolution was a UKRI challenge initiative, and it had been quite a long number of years in actually getting it to the point where the challenge is actually finalised. But this has seen the biggest single investment in power electronics across the UK, and the total budget for this project was £80 million, which, when you see what the actual idea behind it is, it's not a huge amount of money, but this is actually, we see very much as being the very first step on a much longer campaign to really develop this idea within the UK and take full advantage of the opportunities that are offered by electrification across a wide variety of application areas. So the DARE challenge, Driving the Electric Revolution, is a cross-sector challenge. There were 7 sectors here. You can see there's aero, automotive, energy, industry, marine, off-highway and rail. And the ambition of the challenge is pretty bold. I mean, we're really looking to transform the UK economy. That's what the goal is, to make a significant impact on the UK economy. And really the idea is to assist companies. I mean, the whole idea behind it is to focus on the power electronics, electrical machines and drives technology area, and which really underpins pretty much all of electrification. If you think about any electrified system, whether it's it's just providing power to something, or it's making something move, somewhere in that system there will be power electronics, there'll probably be an electrical machine, and there's going to be some kind of control around that to make the whole thing work properly. So this is really underpinning technology. And I think one of the frustrations was that the whole PEMD industry within the UK was quite fragmented. And also a number of companies were finding that if they wanted equipment, they had to look for it elsewhere and not within the UK. So the idea really was to try and bring all this together in the UK and focus it, and to help develop supply chains, which is a very major part of the process of the challenge, and also to develop the processes to manufacture goods in the UK, which would effectively create the UK as a centre for PEMD activity and technology, and which would fully allow us to take advantage of the opportunities that are offered by electrification. So there was a lot of funding up, or some funding up for available. Some of it was for research projects, some of it was for establishing industrialisation centres, along with some other colleagues in academic institutions across Scotland. Strathclyde led a bid to be included within this challenge as one of the industrialisation centres, and we were selected to be one of only 4 regional centres. Again, I won't spend too much time on this one, but I'll just move on to this here, which gives an overview of the centre structure. So we are called DARE Centre Scotland. Our colleagues within the centre are the University of Edinburgh, who have expertise in power electronics and also particularly in the marine area. We have we work with University of St Andrews, who have very good expertise in hydrogen systems, and also the James Watt Nanofabrication Centre, who work in the field of power semiconductors, design and development. So those are the academic institutions. Another part of the DARE challenge, as I've mentioned, is this manufacturing capability. So a very key part of our DARE Centre Scotland was this National Manufacturing Institute for Scotland tie-up, particularly through the AFRC. And that ties us into this high value manufacturing catapult, which is a UK-wide initiative. So that, if you like, supports the manufacturing aspect of what we do. And then on the right-hand side there, you can see, if you like, our unique selling point for inclusion within the DARE initiative was our ability to test and develop at high power. So the PNDC was clearly a very strong anchor point in our case for inclusion within that, as is the HVDC Centre, which is right next door to the PNDC. And as it says here, Scottish Power Energy Networks, and again, a major supporter of us within this. And below all of this stuff, you can see there's also a whole bunch of other institutions and organisations which feed into this DARE Centre Scotland and support it. And so these are mechanisms through which you can interface with us to take advantage of the opportunity offered by DARE Centre Scotland. This, again, I won't spend too much time on this, but this really just gives you a sort of idea of the sorts of things that we are able to do within the DARE Centre Scotland, and where the various partners within DARE Centre Scotland can actually contribute to the various developments and so on, products and that sort of thing that we can drive through the DARE Centre Scotland. It also mentions at the bottom, doesn't mention this one, maybe not. Oh no, it's up at the top left-hand side there. We can see the Hydrogen Accelerator, which has already been mentioned. And again, this is an initiative which effectively seeks to coordinate a lot of hydrogen research activity, industrial activity within Scotland to optimise, if you like, the kind of acceleration and rollout of hydrogen technologies. And Stephen mentioned earlier that there's ambition to include some hydrogen activity as well, actually on the site at the PNDC. And again, we link closely into this hydrogen, this Michelin Scotland Innovation Park, which is also developing the sort of similar, if you like, capabilities, but not identical, for some sorts of aspects of the testing that we will also be able to support within the DARE Centre. And we're supporting them with that. There's a lot of synergy between that activity there and the DARE Centre Scotland. Again, I won't mention too much about the PNDC because I think Stephen's already given an overview of that. I think the important thing to highlight here is what DARE Scotland brings to the PNDC. So all of the stuff that's in the orange colour there is effectively what was already at the PNDC. And that allowed us to do a lot of work on equipment for the energy system. What we are now able to do through the £5 million of funding that we have won through the DARE initiative is to expand that capability to include this up to megawatt scale, if you like, traction testing capability. So these are effectively high speed and low speed dynamometer sets with enhanced hardware in the loop capability and power supply capability. So this really allows us to get into the megawatt scale activity where we can support, for example, people who are companies who are developing aero systems, marine systems, off-highway transport systems, things like construction vehicles. It could be something like buses, electric buses for driving in city centres. It could be delivery vehicles, all those sorts of activities. And also you can see below that as well, we're also looking to incorporate, as Stephen mentioned, these other energy vectors. So just away from the kind of straight electrical input and output, we're also looking at hydrogen storage and heat network systems. The last slide is really just giving a sort of overview. And some of these are a bit out of date now, but I think the most important one is this one here at the very bottom. If people are interested in exploring what they can do with the DARE Centre Scotland, there is an opportunity to bid into a £20 million funding pot. We'll find out much more about the details of that call in the new year. But this is really just to kind of put it on your horizon, and we can direct you towards the DARE information sites if you're interested in doing that. And that's, for example, where you can bid in for funding to develop processes and manufacturing processes and products and so on, and perhaps do that in collaboration with DARE Centre Scotland or even part of the broader DARE network. So I think I've very definitely spoken for far too long, but I hope that's given you some sort of overview. So I apologise for talking too much. Jennifer, I'll now hand back to you.
No, Derek, that was brilliant. Thank you very much for your talk. And it really is just now to see if there's any questions or if we can expect questions later once these go online. There's nothing came through on the chat as yet. I think it might just be a case of we wrap things up there, and thank everybody that joined very much for their time. These will be available online and we will distribute the slides. But any questions, please do get in touch with us. And I think that is us. Thank you very much.